All right, so with section 11.3, we continue driving on with everything that we've been talking about with the mole. Yellow. I have a class. I mean, they can come in here. I don't care. I know Dorfler has a resource. I'm not sure what class he has. Nick does. Okay, yep, appreciate it. Alrighty, so section 11.3, we continue driving on with what we've been talking about with the mole, and we kind of take stuff that we've already talked about, which was our chemical formulas, and we add in the business of the mole. So before we said a chemical formula has certain number of atoms, you know, four atoms of this, 5 atoms of that, to make your formula. Now all we do is we just replace the atoms with a mole. So if we had a mole of Freon, we would have 1 mole of carbon, 2 moles of chlorine, and 2 moles of chlorine. Before we would say, hey, if I have 1 molecule of Freon, I'd have 1 carbon atom to 2 chlorine atoms to 2 fluorine atoms, okay? You're just replacing those terms so that we can apply all of the math business that we have here. So any questions? Anybody need this stuff? All right, let's rock. All right, so how we do this, okay? We use our formula as our conversion factor. So we don't even need the periodic table. We don't even need a fancy conversion because we have all of that information right here in our particular formula. We're going to start out these problems exactly the same, and we're going to copy down exactly what we're given in terms of number and our particular unit, and then we're going to use the formula to come up with that conversion factor. In all of these problems, not only this chapter, but throughout chemistry, your diagonal units have to cancel. If you can think through that concept and make that concept happen, these problems become much, much easier to visualize. Again, what I say is don't be lazy. Write out all of those particular units. Write out all of those substances. It will help in the long run. So, questions? Does anybody need this? All right. So here we go. Aluminum oxide, Al2O3, often called alumina, is the principal raw material for making aluminum. Can also be found in minerals of corundum and bauxite. Important part here, determine the moles of aluminum ions in 1.25 moles of aluminum oxide. Again, I always like to say, okay, this is really fantastic news if you are learning about facts and things like that. We are not. And so I like to say all of that unneeded information, just go ahead and cross out. Okay? I'm going to pick up with this. What we're given 1.25 moles of the compound. So we have 1.25 moles of our formula Al2O3. We say times and we draw our line. And what unit and substance needs to go in that bottom right-hand corner? Moles of aluminum oxide. Yep. Moles of aluminum oxide, Al2O3. And in the past, I would say, okay, let's go ahead and put the other unit, and we'll find the ratio. But I want to pause here and talk about this, okay? If we applied that information from the first slide in this section, we have this idea in mind. And that is 1 mole of the entire compound, Al2O3, can be broken down into individual moles based on the substance. All we have to do is look at that little number, that subscript down below. Okay? And so with this here, AL, if we look here, it shows that we have 2 ALs, and so we really have 2 moles of our AL, and the way we get the 3 plus is the charge of aluminum. Now I'm not too focused on the charge, but I want you to see that, hey, one of the entire compound has 2 parts of that aluminum. So here's where we can get our value here, and here's where we can plug in our numbers. Where we want to end up is going to be moles of our Al3 plus. Now, based on what I just wrote in green, on bottom with the entire formula, what number should be associated with that number of moles? 1. And for aluminum, what number should be associated with that? Just 2. Just 2. Yep. So we'd have 2 moles there, and all we have to do is multiply across. So we would say 1.25 times 2. Now that gets us what number? Yep, 2.5 moles of our Al3 plus. Now, what I also want to show you, we're done with that problem, that would be our answer. But if I said, okay, let's do a similar concept for oxygen, we would start out and we'd have a ratio of 1 mole of Al2O3 equals, if I said, hey, find out the number of oxygens, you would have 3 moles of O, and then we get the 2 minus from our particular charges. Okay. So does anybody not understand how we can take the whole formula and find out the components of the ratio in each and every element? Great. Anybody need this? All right. Well, let's move on here to a pretty important part, and that is the molar mass of the compound. Okay, so the molar mass of our compound, very similar to the molar mass of the element, except we just have more elements involved. Okay, and so we get to this and we go through this, and all we have to do extra on this is 1, look up the items on the periodic table, just like we did in the previous sections, but 2, also factor in our value for the amount or number of atoms based upon the formula. Okay, so I'm kind of jumping ahead of myself here, but what we're going to do is we're going to list out every single element. We are going to look up and identify our molar mass on the periodic table. We're going to use the formula to multiply each atom by the distinguished number, and then we're going to add them all up. And again, this is really key, really fundamental in all of this. Okay, questions? Does anybody need this? All right, so I jumped ahead of this, but I do have my particular steps here. I like to have these steps on these particular problems so that we can use these as we go through step by step each of our problems we go over. So key thing, you get given a formula that says, hey, go find the molar mass for this. You will then list out every single element, every single different element that is in the chemical compound, and you'll look up the molar mass of each of those elements. Now, in addition, you're going to multiply that molar mass by the quantity of those atoms, by the quantity of those things in our particular formula. Okay? At the end of the day, once you've done that for every single element, you're going to add this up, and we're going to have units in gram per mole. Now, I don't put this, but I am going to emphasize this throughout. The per mole, the mole is 1 single mole. All right? And most of the time when we have moles, almost always it's going to be per that 1 mole. There's some rare circumstances where it's not. Okay. Any questions over this? Does anybody still need it? All right, so let's go through this. So we want to find our molar mass of potassium chromium, K2CrO4. So the first thing that we need to do is we need to list out every single element that is in our formula. So I'm going to list out K for potassium. I'm going to list out our Cr for chromium. And I'm going to list out our O for oxygen. Okay, now we look up on the periodic table and how many decimals do we round to for each of the molar masses here? Do two decimals here. And so if you look up potassium, K, we get a molar mass of what? 39.1, and we put the 0 on there, and that's just me being me for that 2 decimals, and that's in units of gram per mole. Then we say times, and we multiply this by the number of Ks, which how many Ks do we have? 2, and specifically that is 2 moles of K. Now, when we take 39.1 times 2, we end up with a value of 78.20, and we just call that grams. I'll tell you why or how we kind of get back to that grams per mole at the end of this. Then chromium. If you look up chromium, it's a weird one. It's like 51.997. It rounds up to exactly 52.00 grams per mole. How many chromiums do we have in our formula? Just 1. Technically, it's 1 mole. And so we get to this. We say, all right, our green number for chromium is 52.00 grams. And then we get down to our final element that we have to worry about. And we say, all right, oxygen, it has a molar mass of 15.997. So another one that rounds up to that next whole number. And so it would round up to 16.00 grams per mole times how many oxygens? 4. And technically it's 4 moles. This, if we multiply this out, would give us a value of 64.00 grams. Now, what we do at this point, our pink, green, and purple number, is we have to add these all up. So if we add all of these up, what number do we get for our molar mass? Yeah, 194.2, and technically to keep that second decimal, we keep it 20. That would be our grams. Now, that number is equal to 1 mole of our K2CrO4, but more commonly, you're going to see this not written like how I have it here. More commonly, you're going to see this written simply as 194.20 grams per mole. And that's where we get, again, our molar mass and our units of grams per mole. Okay? Any questions over this? All right. So we'll go over a couple more slides here. Remember, the next problem that you do was that handout that I gave you had to substitute the slide that was in your particular notes. Okay? Questions? Anybody need this? All right. Oh, anybody need it? All right, so hang in there, almost done. Now, what we can do is this. Now that we know how to get the molar mass of the substance.
All band members need to report to the band room, and all band members please report to the band room.
So our final item of the day here is using that molar mass and going through our conversion, okay? And so with this, I taught you how to calculate the molar mass. And so problems like this that use the molar mass, you just have to know how to, number one, set it up. Number two, use the molar mass. So to help speed things up, I've incorporated the molar mass in grams per mole, but just know how I found that was the same exact way that I went through on that last problem. Okay? Any questions? Anybody still need this? Gotcha. All right, so again, turn to the handout here, and we will go through this particular problem here. Let me update my board here. And this should be the handout here that I just gave you. Okay, so we have allyl sulfide. Here is our amount of 2.5 moles of allyl sulfide, and we have the molar mass that's given. Again, always start out and copy and paste exactly what is given, not the highlighted information, but what would be contained in our particular problem, which is 2.5 moles of allyl sulfide. So we'd write down 2.50 moles. Allyl sulfide has a weird format or weird formula, but it's C3H52. And then you have the S for sulfur. Then you'd say times, and you draw the line. What unit has to be in that bottom right-hand corner? Yep. Mole of that allyl sulfide with that odd-looking formula. Okay? Now, on top, we want to go to G for grams. And that's going to be G of that allyl sulfide there. And so here's the question I have for you. Is this allyl sulfide has the molar mass 114.21 grams per mole, which I calculated the same steps that I used in the previous example, just with these specific substances. 114.21 is attached with G for grams. And so it's going to go next to that G for grams in our conversion. And it doesn't explicitly say this, but this right here is per 1 mole. So we're going to have 1 mole. Now, all we have to do is calculate this particular problem out. And we end 2.5 times 114.21. We end with this. Going to 3 total digits, we actually round to a whole number here. We would end with 286 grams of C3H52S. Okay? Questions with this? You will be given, unless it's a problem that says, go find molar mass, tell me what the molar mass is, you will be given the molar mass. That way it kind of speeds up those problems to get to where we actually are end objective there. Any questions?